Thank you very much for joining the webinar. My name is Barbara Osiro. I work at Qhala under the AI Literacy Movement project. For today, we have an amazing session where we are going to discuss responsible AI and ethics, and especially in our local context. I would like to welcome our instructor for the day. So ladies and gentlemen, help me to welcome Dr. Fred Mutisya, who will guide us through this session.
Thanks, Barbara, for the introduction. For this talk, we will be looking at ethics and responsible use of AI in Africa from the health lens. So even as we start, I'll just give you 1 minute to take this in. These are very common headlines these days. So let me just pause there, take in these various newspaper headlines. Yeah. So yeah, there are claims everywhere, and not just in health, but beyond health, about AI outperforming humans. For me, as an AI practitioner, I'm really bullish about AI, but also understand that sometimes a technology might be mature in one aspect, but also be immature in another. And even when you look at the issue of replacing technical people, like doctors and teachers do more than just document or diagnose, they do a lot of other things. So we'll be exploring the ethical aspects of AI, and you'll be just using health as an example. But these concepts cut across all of AI, whether you're talking about finance, advertising, etc. So yeah, I like doing this. And I think I last ran this model a few months ago. And the question is, are you smarter than AI? And so what we'll do, I know I can't see the chat box, so I won't even attempt to look at it. But I will give you again 2 minutes to try to answer any of these two questions. Imagine you are given in your KCSE exam, this is like let's say like section 3, where you're told answer 1 out of the 3 or 4 questions in the section. So I'll give you again 2 minutes to look at what you have here and choose which question you'd prefer to answer, and just put your answer in the chat box. Again, I'll give you one minute for that. Unfortunately, I'll not be able to see the chat box, so but we'll just continue from there. But I'm sure a lot of you chose question 1, yeah? But you might find that some very ambitious 844 people who were like, no, me, I like challenges. Let me look at this one, which has weird symbols. It's talking about weird stuff, rheumatoid arthritis. It's talking about Bayesian hierarchical models. And for us as humans, regardless of which field you are in, question 1 is the easier option of the two. But the funny thing about AI, and that's where Moravec's paradox comes in, is it's not as straightforward as it is for us. So Moravec's paradox comes from robotics. And I'm sure you've seen all these funny videos of robots trying to play football, falling. And people are saying, oh, AI is, if this is AI, I'm safe. Yeah. And it stems from Moravec's paradox. So Moravec's paradox basically says what is easy for humans is hard for AI, and what is hard for AI is easy for humans. And what that means is I have now a child who is about to become 3 years old. So my son, who is 3 years old, he's a toddler. He can't speak very well, but his fine motor movements, like in terms of running around, jumping, handling a glass of water, they exceed any robot currently in production. Yeah. And that's the funny thing about compute. Compute in terms of when you think about simple things like how many dogs do you see in that picture? As we are like, yeah, obviously this is a dog, this is not a muffin. But computers, because they're using ones and zeros, their methods of computer are much different from ours. So something as simple as jump and or open this door and close it, things which are simple for us, which in our minds we are like just opening a door. But the number of computations needed for us to extend our hands, turn the knob, feel that the knob has gotten to the last point, pull it the right amount of to get the amount of working space, and closing it behind us is not as for us it's easy, but the amount of computations that it takes for a robot to do that, they approach the billions. And the same thing for looking at differentiating chihuahuas and muffins. For us humans, we have an innate thing of how we identify eyes and noses. And already we've seen so many chihuahuas that we know, oh, this is a chihuahua. But for a computer, they use these rules. Even for the machine learning, they still use some level of, okay, if you see two eyes and a nose in a triangular fashion, that looks like a dog. But when you change the angles, you have these weird dogs with weird angles. And especially in the last row, the third box, that's where a lot of the models failed. And that's the box which has more than one puppy, yeah? And one puppy has been cut, like the image is not complete. Those are things that you know, okay, there is a puppy there. Even if I see it partially, there is a puppy there. But models are becoming better and better, but this is one of those things that remain. And this is a deep dive that people need to do, not just in health, but in all other things, because it's very easy. The question on doing modeling for Bayesian statistics, very easy for a machine to do because it's just ones and zeros and putting it all together. So what we think is easy for machines and it'll do well, it'll write for me my essay. But there are things that are intuitive for us but are hard for us. And that's what is important even as you're thinking about ethics and AI. But let me now take a step back. We are in AI Literacy Week. I know we had a session on what is AI yesterday. So I'll just use 2 slides to remind us what AI is. Then after that, we can continue. So AI basically is just computer systems which can do tasks which typically require human intelligence. That's what it means. And these tasks can be divided into different things. So AI in itself is not a new term. It's been there since 1956, where it was coined in the Dartmouth Conference. And the overarching term of artificial intelligence has so many subcategories. So you have machine learning, which in the 1970s where it really picked up steam. And basically it's just statistics and mathematical modeling on steroids. So instead of starting and concluding with the data, you let the data tell the story. Deep learning really peaked in the 2010s. So in 2012, there's what is called AlexNet. There had been this big challenge called ImageNet, which was trying to differentiate between cats and dogs. And it's funny to think that that was just barely 14 years ago, yeah? Where the best AI models, the best that they could do is to differentiate cats and dogs, yeah, right? And this is just images, not videos, not audio. But we've come so far from there. And now we have this intersection where we're talking about generative AI, transformers, large language models. And that's what conventionally people talk about AI. And when you're talking about each big company, whether it's OpenAI, DeepSeek, Claude, Gemini, Llama, um, all of them have generative AI models. And even Moonshot has Kimi as well. And more generative AI models are coming. And when we talk about ethics of AI, we can't just focus on generative AI, yeah? Because as we mentioned, generative AI is a subset of a subset of a subset. And when you look at it, you have to look at the domains where it's operating from. So the 2 domains basically are saying, we said AI is basically computers learning how to do human tasks. And the 2 big categories of human tasks are language, yeah? Understanding language, understanding and processing language. So you are able to understand it and generating language. And language has different elements. It has the element of written speech, spoken speech, etc. Then computer vision is just teaching a computer how to see, yeah? And seeing moves from image to the spectrum of videos, because videos are just images stacked together in rapid succession. So now that we have this, I'll just give this as one of the last foundational slides on, as I mentioned, machine learning is explainable. And even when we talk about ethical AI and explainable AI, machine learning is the first step in terms of building out AI. And it's the analogy of, if you don't want to respond to a mosquito bite with a hammer. Like if machine learning can do it, use machine learning. Don't use fancy neural networks for something that can be explained using machine learning, because it's explainable. Like you can tell people, I have a model that predicts which women are at risk of death from after birth. And when people ask you, okay, why are you saying this? Then you can be able to go back to the model and say, oh, by the way, it picks people who live out far from the facility, yeah, or people who had a pre-existing condition, yeah. And you're able to give this to the policymakers, and that's the whole purpose of ethical AI. Ethical AI is supposed to help people address a problem and not just tell people you have a problem. So, for example, if you identify those are the risk factors, then you can be able to quickly address them and say, okay, then how do we help these women not die? Then let's bring hospitals closer, let's have ambulances, let's have mobile clinics, etc. And all this comes from having an architecture that is based on machine learning, explainable AI. However, deep learning is where now you're talking about neural networks, you're talking about transformers, and in the largest sense of it, it tries to replicate the human brain. And the human brain, in the same way that I'm speaking right now, yeah. I prepared these slides last week, yeah. However, these slides, some of them, I got them from when I was doing my master's in data science. So some of the knowledge I'm retrieving from my classes in data science, something that I read randomly two weeks ago. Then all this is coming as I'm speaking. My eyes are looking at the slides and I'm getting some cues from that. I'm speaking, you can see my hands moving, and that's the totality of me doing this presentation. But if you are trying to find out which part of the brain exactly has stored this knowledge that is called neural networks, which place in the brain has this thing of multi-layer perceptrons, yeah, this thing that is in number B, where in the brain is it exactly stored? And how is it stored? How does he explain it? Like, you can't tell that. Like, even if you have a functional MRI which lights up, depending on which part of the brain is activated, it doesn't tell you where exactly you're getting this information from. It's not explainable. And that's the same analogy with deep learning. It's not explainable. And even now, as we're talking about ethics of AI, we have to ask ourselves, is telling somebody of a problem, is it good enough? Or do we need to go and explore different ways of making deep learning explainable? And people are doing a lot of work in trying to make deep learning explainable. People have tried with chain of thought, trying to look at having the AI, especially with LLMs, explain their steps, but still there's a big gap in terms of making deep learning fully explainable. So I'll do the building block, then we'll talk about some current ethical issues. So with building blocks, as we're talking about ethical AI, we have to think about data. Data has to be of good quality, and not just good quality, it has to be indigenous. So don't bring us a model for skin cancer that has only 5% black skin, yeah? And not just black skin, it can't just be like light skin. It has to have all the diversity of skin color that we have in Africa. So it has to be indigenous data. It has to be unbiased, meaning that if you're talking about, like, there are people always talk about, oh, we're using social media to predict XYZ. Just by using social media, you're excluding so many people. And you can't use that for example, in African public health policy, because a lot of people are not on Twitter. So you're saying I'm using Twitter to determine XYZ. That is bias. You're doing selection bias. So the quality of data needs to be unbiased, meaning that everyone needs to be represented there in the same way that they would be represented on the ground. And last, it has to be accurate. Big data has these categories where it has veracity, meaning that it has a lot of errors. So when you're talking about getting a lot of data from the public health sector, you realize that not everything that everyone has put on social media, if you're scrapping social media, is accurate. So you can't say, oh, I have this model that is being built on the internet that helps diagnose XYZ. First of all, things move in health. What was accurate during the COVID times is not accurate now. So, for example, if you're trying to, there's this model that was used to diagnose pathology from coughs, and the data came from COVID. And every time it used to say COVID, and just because everyone had COVID that time, it had a very high accuracy. But try to run the same model right now, it will fail. Why? Because the data it was used to train on was accurate for the time, but because it's not up to date, it makes it inaccurate. And lastly, as you're talking about data, we have to think about quantity of data. So there is synthetic data, and a lot of people are using synthetic data right now to expand their data. So they extrapolate data. Is what is called SMOT, which is a method of doing synthetic minority oversampling. So if you have, let's say, like you're doing a study on the tribes of Kenya, and your Okiek or Gabra samples are less than 100,000, you're able to create synthetic data to increase that to 1 million. But there are also challenges on using that because you are amplifying some biases. So all these are ethical considerations as you're thinking about AI. Then there's the models. So the other building block for AI is the models. And with models, it's almost like having a building plan. Yeah, a building plan of, okay, this is what I need. I need to have a hospital, I need to have a bus station, I need to have a supermarket. The model is like the building plan because that is what the form will follow functionality. So you're talking about vision models, natural language processing models, or multimodal models. I know this was talked about by Keith yesterday, but basically the whole gist about this is for Africa, we have to very jealously create our own models. You remember the story that came out last week where we had the models from Claude Anthropic, that is Claude Mixel's, being banned for the US exercising its sovereign power, banning the models for non-US people. And Reflex, Anthropic said, okay, we can't ethically just ban it for non-US citizens, we'll just ban it for everyone. And this is also the importance of models being ethical in terms of being open sourced and being available, and us having our own models which are sovereign. The other building block is construction workers. And as we talk about, like, you're building that building, you have to have your surveyors, your engineers, your architects, and it all comes to talent. And even as you're thinking about ethical AI, we have to have our own talent, because our own talent are the ones who will know what we need for Africa. And it's that whole ethos of build for Africa by Africa. And when you think about construction workers, there's this whole spectrum of everyone who helps make the data AI ready. That's the data engineers, the data scientists who are concerned with the architecture, then the ones who make sure everything runs well. That is the machine learning ops. So we need, part of ethical AI means that we need to have our own workers, Africans who know our problems so that we can build solutions that speak to our reality. Then we have the construction equipment, which is compute. When you talk about AI ethics, it's hard to speak about it without the issue of compute. Because again, remember, a lot of the data that is being processed on GPT, on your cloud models, it's been computed not in Kenya because you don't have those servers here, they're in the US. So in case our dear president in Kenya, we say chokoza, meaning you step on the foot of the country which has these data farms, all they need to do is to say Kenya is a persona non grata, shut it down, and suddenly we don't have access to the API models that we know and love. So it's also important to have our own compute, even as we're talking about ethical AI. So we'll talk about different ethical questions, then we finish. So we have different ethical questions with health. And especially with the AI bill that came out, it's what makes us realize that health is not equal. Like the level of scrutiny that you need for an AI tool is not the same for everything in health. So, for example, here, this is a workflow of somebody who comes to hospital. They come So there are those reminders that tell you, oh, you have your appointment. I was taking my daughter for her 9-month vaccination last week, and that just that message which is personalized that says, oh, you need to go to hospital, blah blah blah. Those nudges, yeah, that is very low risk in terms of you're not intervening, you're not giving somebody medication, you're just giving them a reminder. Yeah. So, for example, somebody that's basically improving health seeking behavior. Then, when they come to hospital, you have to choose who will be seen first. And this is that thing of you have a long queue and you are wondering, okay, who needs to be first? Is it the person who is shouting? No, no, no. Actually, it's not the person who should be shouting who should be seen first. It's the person who is silent and sleeping, because that person might have low sugar and might have just passed out. So these are the things that, in terms of AI and danger sign identification, using Internet of Things connected with bands like wellness bands or random blood sugar machines or blood pressure machines that are able to identify people who need to be seen faster in hospitals. That's very important. Then we have clinical decision support. Yeah, here is basically you're with your doctor, and it's just helping your doctor not miss anything. And the key thing is support here. We are saying AI is not replacing doctors, but it's helping them sift through a lot of information and support the decision making. So it's almost like having an extra doctor there. So people are tag teaming to ensure that nothing is missed. Then we have AI-enabled histopathology and radiology. And here is basically you have an image, like you have an X-ray, and you're just trying to figure out, okay, can somebody explain to me this in simple language? Yeah, those are different ethical questions. Like, how do you make AI more relatable and understandable? Does it need to be in Kiswahili? Does it need to be in Kijaluo for it to be actually relevant to our situation? Then, lastly, home-based care. So you're talking about remote patient monitoring, wearable devices, etc. So what you notice is this spectrum is very wide. So even as you're talking about ethical questions, it's not like we'll say, oh, for health AI, it's very, very, very sensitive. Let's regulate it all. You can't do anything without a license. Like it's very broad. So even as you're thinking about ethics, you have to think about it in that regard. Then there's this whole other aspect of the biomedical industry. So this is like in drug discovery, like there's this antibiotic called abaucin, which was developed using AI. And just basically AI was able to help the makers of the drug figure out what works. And also there's in research hypothesis generation. So there's this model from Google called Google Co-Scientist, which takes in so many papers and research articles, and it helps you think through a research idea. So it helps a scientist think through, okay, has somebody published on this? Is there a paper on this in Africa, in Kenya? Has anyone done this? It helps you think through that hypothesis generation. And it's important for ethics because if you have a model that is biased towards the West, it means it will bias you towards research that is based on the West. So also that's why it's important. Supply chain optimization. So for example, vaccine supply. And here the ethics come when you're talking about what type of model you're talking about and how things are delivered. So for example, in the West, people don't use pharmacy for diagnosis. They use pharmacies for prescriptions. In Kenya, for example, people use pharmacies for diagnosis. Somebody will go to the pharmacy and say, I need something for my tummy. And the pharmacist will ask, okay, what exactly is it that you're having? Heartburn? Is it that you're having constipation or whatever? And you'll find that the pharmacist does diagnosis and prescription. So all these things are important in thinking of what's the setting before you make an AI solution, and those are big ethical questions to answer. There's issue of epidemic surveillance and response. Then the issue of insurance. And with insurance, I'll mention that there have been models which have been shown in the West that unfairly discriminate against some certain groups in terms of it's called um, it's called wealth, like in terms of their wealth index, and you're looking at is somebody able to pay for this? So, for example, I work in the next to the Mara, so that's where I practice. And when you're using the tool, like for example, what to use in Kenya for SHA, it will ask, okay, where do you live? Is your house cemented? Does it have an iron roof? Does it have tiles? If you say you live in a mud house, it will say, oh, this person doesn't have money. But initially, that was what they used it before. But with SHA, they shifted it to assets. So, for example, if this person who is living in a thatched house has 200 head of cattle, this person has more disposable income compared with the person who is living in a rental house in, for example, in Kibera. So these are issues that if you don't do the AI modeling very well, it will cause inequities. Now, as we finish, we will talk about what happens when AI gets it wrong. So, for example, this is an example of rheumatoid arthritis, which affects the hands. And we have scenarios where there are false positives. So, false positives means the AI says you have a disease, but the disease that isn't there. Yeah, that is not so bad. What is bad is what you see on the bottom right, the false negatives. False negatives is basically saying, oh, you're good to go, your x-ray is perfect, and yet there are pathologies. So like the bottom right, you can see there's an error. It said this is okay, but you can tell clearly that there's something wrong with that person's hands. So false negatives are a big issue. So even when you're thinking about balancing between false positives and false negatives, would rather lean to reduce false negatives, because with false positives, you can always have the human confirm them. But with false negatives, once you've told somebody you're good, go home, that's it for them. Then now, the other thing that we'll talk about before we finish is AI performance. And for AI performance, like we are writing the AI guidelines for health in Kenya. And the one thing that every regulator asks is, what's the performance of this AI model? Yeah. And we take them to what is the acceptable threshold for performance for AI. So, for example, in the US, close to 500,000 patients each year are hospitalized for some preventable harm, meaning harm that has been done by a doctor, by a nurse, and it comes from like a wrong dose, a wrong drug. Somebody forgot to test you for something and they were supposed to test you. So 500,000 of these preventable harms. And we have over 200,000 deaths, which are due to preventable medical errors. Yeah. So that's our baseline. So when we have scenarios where people talk about, no, 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 we don't want AI which causes any deaths, and yet the baseline is 200,000 deaths. And this is the ethics of AI performance. People come with a model that like says, oh, I'll use the example of driverless cars. So, for example, like in the West, like we have for human accidents and deaths caused by humans in cars is unacceptably high. But if you are to have a driverless car which is driven by AI with only one death, that will be newsworthy. That will be newsworthy. So there's this debate that what is the acceptable threshold for performance of AI in any sector. And people ask, okay, some people are of the thought that we want no harm or deaths from AI, zero, yeah. And some people are are more pragmatic and saying, okay, we can just use like a threshold of let's say like half of humans, and there are people who are like, at least be better than the human, yeah, at least be just better than human for you to come into the field. And this is still unanswered. I don't have the answer to this, but I'm just showing you what people go through when you're trying to take a model to production. Then there's the issue of AI liability and duty of care. So this is a fictitious case. NM, who is a client of Dr. JA, again, fictitious. They have this AI-powered cancer screening tool with a sensitivity of 99.9%. So 99.9%, just to make it grounded, means that if you had 1,000 people, it'll miss one person. It'll have a false negative of one person. And you know, even when you're in school and you get 99% in class, that's not bad. That's not bad. But when you now think about in a population level type of deployment, here you're talking about um, like if you are to scale it to 1,000,000 people, you are talking about 1,000 people who have cancer, who are told they don't have cancer. Is that acceptable? And that's why when you're talking about these metrics like sensitivity, accuracy, we have to be very careful, because a 0.001% percentage point might not be much, but when you're now talking about launching something that impacts millions of people, that error propagates itself. Yeah. So here the case is, again, fictitious case. There was cancer which was missed and it was picked 2 months later. The client, who is NM, wants to sue. And the question is, who is liable? I like this Spider-Man meme, because you're asking, okay, is it the doctor? Is it the hospital? Is it the AI developer? And again, I don't have answers for this, but WHO in its LLM guidelines has tried to give some light to this. And the whole point is the issue of joint liability, meaning that everyone in the whole ecosystem of AI development to deployment has to have a role in ensuring that it works well. In the same way, like for health, we still have the same concept of joint liability. So, for example, the drug that the patient will get, the company is liable for anything that happens regarding that drug that has been developed. The hospital also has liability insurance in case anyone falls or anything happens while in the hospital. And myself as a doctor, like every year we are required to have liability insurance for anything that will happen. So I dunga somebody sindano and I wasn't supposed to dunga them. Liability insurance takes care of that. But what you notice is that everyone, so regardless of where the mistake happened, these people are accountable for that part. So it's not like in other fields where your AI developer makes a solution, then just throws it in the wild and says, oh, may I just made my solution, it's in the wild. I have no liability, I just put it out there. So even the way people put the type of Creative Commons license have to be very careful in terms of your Creative Commons license has to ensure that you put very strong liability disclosures, yeah, so that you say, I'm not liable for this. If somebody takes it and changes it and makes it, militarizes it, that's not me. That's the type of thinking that needs to happen. And if you are an AI developer, this is something that you need to think about even as we get to legislation for AI. So I'll finish by talking about some of Qhala's work in AI, specifically in ethics. So again, we question these headlines, and we ask, is this true for Africa? And we have this paper, we can go and look at it, which looks at the representativeness of these large language model benchmarks for African disease burdens. And basically, what the whole point of this is, be curious of the solutions that you are in front of you. Ask questions from the perspective of Africa so that we have better and ethical AI in the continent. Thank you. Welcome any questions. Okay, let me just do the run through of questions from the. I'll start with the chat box, then go to the Q&A. Sophie asks, you mentioned that AI chatbots, for example, that are being used in African healthcare contexts are typically developed elsewhere. So before AI systems are deployed in African healthcare settings, is local validation on African patient populations typically required, or are models often implemented based on validation conducted elsewhere? Excellent question, Sophie. And that's the whole point of this discussion. Because right now it's almost free for all. People will come with their own solutions and directly just apply them here. So, for example, you are in Muhimbili, in Uganda, and because somebody has funding from USAID or some big funder, they'll come and just say, this is what we have, no co-creation, no co-testing with us. Because also we are saying we don't want at the downstream. We want, once you're ideating even the concept, that's where Africa needs to come. Not even, that means even before thinking of making an AI model for Africa, it has to start upstream. And currently what we are doing, like in Kenya, our guidelines and what the Digital Health Agency is trying to do is it's creating an accreditation system for AI models so that we can test them locally with local data so that we see whether it's fit for purpose. So how this will look like is, for us, for example, with drugs, when somebody comes with paracetamol, maybe it's called Tylenol in the US, before it's registered in Uganda, the Ugandan medical agency needs to test the drug for its claims, see does it work for Africans as well as it works for the Caucasian population, and then gives it a license. It's the same theory with AI. But remember I said AI has the different spectrums. So for example, an AI which is a reminder, do we need it to be tested for the population? Maybe a bit of language, but not too much. But AI for diagnosis, and with diagnosis also fractures, bones as bones, whether it's Caucasian or African, not bigger difference. But when you're now talking about skin, you're talking about our genetics, you're talking about cancer, we are very different. And hence those ones need like very rigorous testing with our populations. Oh yeah, Muhimbili is in Dar es Salaam. Oh, apologies. Yeah, Muhimbili is in Dar es Salaam. So yeah, the same example for in Dar es Salaam as well. I'll now go to the Q&A. So Patrick Miner asks, is it possible to use safe and ethical LLMs as judge during AI model training to reduce the issue of the word of reinforcement, RF? Okay. So great question. So we've like in some of our own research, we've tried LLM as judges, and even one of them, the benchmarks called Health Bench from OpenAI uses LLM as judges. But it's almost like using the whole point is LLM as judges are okay, but you have to ask which is the LLM that is being used as a judge? Is it also an LLM that has been trained in the West? Because it's almost like saying, okay, we'll use an LLM as a judge, but again, the judge is a European centric type of LLM or global North LLM. So it brings that LLM and judges are good, but the LLM that is chosen needs to be grounded. And we need to replicate what is done in the West in terms of the West did a lot of human reinforcement learning, and we need to do the same. So initially with LLMs, the investment was not in data centers, was in ensuring that we have good data. And we need to go back to those roots so that we're not talking about building a data center in Africa or in Kenya. Let's start with ensuring that our data is represented. Let's capture the different dialects of Tiriki or Maragoli in Kenya, or let's capture the different dialects of the Igbo in Nigeria, or let's capture the different dialects of the Ankole before it disappears. That should be our priority as Africa, because I feel like when as you're talking about contextual LLMs and LLM as judges, you can't use an LLM as a judge for, let's say, like trying to deploy something in, for example, in Tanzania, where you're talking about Swahili, and this model is not Swahili native, meaning everything needs to start from a Swahili cultural perspective, and that should be the judge for, let's say, deployment in Muhimbili environments in Dar es Salaam. So that's the type of thinking that we're thinking about. Quincy asks, in the alignment scene, which medical standards do you use as a basic governance metric? So I will direct you, just go to archive, Google my name, Fred Mutisya Qhala, and you'll see our paper there. We've done a deep dive of the different standards that are used because they're different. Yeah, it depends on what you're talking about. Because as I mentioned, the health AI is so wide that your metric for a solution that just does reminders for coming to clinic is highly different from one which helps decide who needs to be in ICU or not for a chest infection. So in that regard, I'll direct you to our paper and you might read more about that. Okello Crystal asks, where would you say we are as a country in terms of data collection availability and usage? Somebody once told me if I want a career in data and AI, I should probably consider moving to the West. Yeah, that's a good question. The good thing about AI is that, for example, right now I'm playing around with it's called Gemma 4, the 2E2B model. And this model basically it's like state-of-the-art model made by Google, and I can play around with it because I have a GPU in my house. And basically, the tech and AI has been democratized to a point that you don't need to move to the West to get to be familiar with these tools and these solutions. Like literally, you can start building your career here. We have a lot of thriving AI companies here. My first AI gig, I got it just because I did a paper, went to Barcelona, did a presentation, then got a gig with a European company. So there is that argument still to be made that we might not have as many opportunities in Africa, but you don't need to move to the West. You could always work remotely. And actually, they like people from here because you're almost running a 24-hour type of system. Because, like, by the time they wake up, you'll have been done with your work. That really is good for them. So you don't need to move to the West. However, you need to have your work visible to the global north as well as the global south. This means publishing as much as possible, doing research on the models, and just even publishing open source. Put things on GitHub, put things on LinkedIn, connect with as many people as possible. That's how you build a career in data science, not just by moving, because you'll move, but where will you get the job? Like you still need to have some track record for you to be invited there. And I'll finish by saying Africa is the next frontier for AI. We are 500 million people are less than 21 years of age. These are people who are the next AI native generation. So I feel like you need use the skills from elsewhere, everywhere. Also, China. China is a very thriving place. Try the Quen models, try the moonshot models. Learn from everyone, but always think of Africa because I think that's where the next frontier will be. Sophie asks, do you see limited trust in locally developed AI innovations as an ethical challenge for Africa's AI ecosystem? And what can be done to encourage equitable adoption of initiatives such as Masakane? Yeah, that's very true. Initially, people equated open source with cheap, but it's becoming more and more clear, especially with the excellent performance of the open sourced Chinese models like Quen and Kimi. What is being apparent is that sovereign AI can outperform these commercial API-based models. And first of all, we have to be honest. And now to answer your question, Sophie, is that as innovators in Africa, we have to be honest. If we are fine-tuning a model that is based on American model or a German model, we have to be clear and say, this is not Africa's first AI model. We have to say this is a fine-tuned model, but the architecture is based on Quen from China. It's based on Gemma from Google. We have to be honest by that. That's the first challenge of the limitation in trust, because we have a lot of companies which have big claims. Then when you go to look at the documentation, you realize these guys are running a GPT wrapper, and yet they are saying, oh, we have this, our own model. So that's the first part of developing trust, being honest with where we are. And innovations like Masakane are the step in doing that. You can't fine-tune a model. You can't pre-train a model from the ground up as an individual. You have to plug into initiatives like Masakane and build it together. Yeah, build it together. And that's why donating data is a big thing for me. And that's why, like, a lot of data that I have, I just put it. And that's why we publish stuff. You publish it, you put it online, because you realize you can't do this alone. And that's how we build trust. We put what we are doing for it to be examined. You put the methodology, you say, this is how I did it. And you let people judge. And that's how we grow. And I would say just anyone who is on the call, go and see what Masakane does. They do exciting stuff and also plug into these communities. Yeah, I don't see if you have any more questions, and we are 4 minutes to the top of the hour. It's been such an honor speaking to you on this Literacy Week. So in case you need more information, yeah, Masakane. So let me just put this also in the chat box. So in case you need any, in case you need any more information, just continue plugging into the Qhala social media pages, which Barbara has shared. Yeah, feel free to connect with me on LinkedIn. My name is Fred Mutisya. Just Google me. You'll find me. And again, let me just type my name. Connect with Qhala on the socials. And let's build for Africa even as we're thinking about ethical AI. Thanks, and back to you, Barbara.
Wow, that was an amazing session. Thank you very, very much, Dr. Fred.